Keeper 8.5, slope fields. All right, so a slope field is basically a graph or a map or a vector field that allows you to see the solution of the antiderivative or of the integral. So your steps for creating the slope field: first you're going to create an XY table. And you don't necessarily have to write it down all the time. I suggest you do it at first just so that you can see what you're actually plotting. But a lot of times, especially if you're doing a big slope field, you'll do it kind of just doing the calculations in your head. Then step 2, you want to plug the x values into f prime, and that will give you your slope, because remember, f prime is the slope of the function. So step 3, you want to draw a short line segment that represents that slope. So like if you're drawing a slope of 1, you want to draw a line segment that looks like a slope of 1. Or if you're drawing a slope of -5, you want a steeper line that's kind of going in a negative direction that represents -5. All right, so our first example, we have f prime of x equals 1. So if I do an xy plot, I'm going to use any x values that I need to plot. So in this case, I'm going from -3 to 3, since that's where the dots are on my graph, or that's what they're asking for. And then my f prime, I'm going to plug in my x values into my derivative. But since my derivative is 1, every single f prime is going to be 1. So all the way down, no matter what number I plug in, I'm getting the derivative out of 1. All right, and so when I go to draw my lines, as you can see, I'm doing a slope up, and I'm making it slope up at a little angle of 1. So like almost like the line y equals x all over the place. All right, this is telling me the answer to my my differential equation. In other words, well, these look like straight lines, so I believe that the answer to this would probably be linear. All right, like f of x equals x plus some c, and that's why you have varying levels of lines. All right, the next one we have f prime of x equals x plus 1. So I'm going to start by writing down my x values that I want to test, and then I'm going to plug those x values into my function. So I'm starting with -3, plug that in, I get -3 plus 1, which is -2, and then -2 plus 1, and so on, and I just keep going in that fashion. And so what this is telling me is that at -3, so the first one I did, at -3, I want to draw a slope of -2. And then at -2, I want to draw a slope that looks like -1. And at -1, I want a horizontal line because I want a slope of 0. And so if I keep going and do all those, I should see something that looks a little bit like this, which kind of looks like, if you were to trace or kind of like go with the flow of the lines, it kind of looks like a parabola. Now this one I did by hand. I'm going to show you guys what it actually looks like so that you guys can see it. This is the actual slope field that I did. And you see that my slope field was very similar to this one, whereas, like I said, you can kind of see it looking like a U-shaped graph. In other words, if I was to guess at what the answer or what f of x is, I would say that it's some type of x squared plus c, or maybe x squared plus x plus c, or x squared plus 2x plus c, or something like that. And we can actually, and we're going to learn how to do this later, how to actually calculate or find the answers to our differential equations, the exact answers. All right, so next one we have f prime of x equals x over 1. Again, I instead of just picking x values, I want to use the actual points, because the derivative function has both x's and y's in it. So I'm going to do like the point 0, 0, then I'm going to try to point 1, 1, and 1, -1, and even 2, 2, and 2, -2, and 3, 3, whatever. I'm going to do all the points possible. I'm going to plug it into the function, and I'm going to see what it gives me. And so once I get that, I'm just going to plot my, like I said, like I've been doing, plot my little lines. So when I do that, and here's just a couple of them that I started to plot, I start to see kind of like a pattern. Now, of course, you guys would finish plotting all the rest of these, right? You would plot every single point. Like I would come up here and I would plot, I'd figure out what 1, 2 is, and then what 1, 3 is, and then what 2, 3 is. I plot every single dot, and when you do that, your final graph should look something like that. All right, and so again, you kind of should be able to see the shape of it. Kind of looks like I don't know, like a hyperbola type thing. I don't know what it could be. It might be, it looks like a hyperbola to me, so I would have guessed at a hyperbola if I didn't already know how to solve the problem.